9.2, parabolas. Let's go. Equations of parabolas. Now, the definition of a parabola, we've actually never gone over. We know what it is, but the definition of it is this. It can be defined as the set of all points in a plane that are the same distance from a given point. That point's special name is the focus. You will see that darn near every section of this chapter, a focus. And a given line called the directrix. Typically the focus, not typically, always, the focus is on the inside of a parabola, right here. The directrix is a line that's below it, like this. Alright, so that's the directrix. That's the focus. This line's called what? The axis of symmetry, that's still there. Okay, then obviously the parabola. So a parabola is a set of points in a plane that are the same distance from this point and this line. So for example, the distance between here and A is the same as the distance, whoops, pop back up, there you go, between A and this line here, the directrix. Okay. Understand, you won't need to define that, okay? What is going to be helpful for you though is to understand the relationships between the directrix, the focus, and the axis of symmetry. That's going to be helpful.
What's the point of the centrics? Like, what is the purpose of the disciple?
It's the line that helps you graph it if you don't have like the function itself.
Oh, okay.
Okay. Understanding, because here's what's going to happen. This is why this isn't like parabolas that you've ever seen before. These parabolas, instead of opening up and down, they're going to open left and right. Okay. That's what makes these conics. Conics are not functions. Conics are circles, hyperbolas, ellipses, and then sideways parabolas. Okay? So these aren't functions. So everything in your head about functions pretty much goes out the window, because these aren't those. Okay? So understanding the formula for a directrix line and the formula for an axis of symmetry line becomes important because that helps you orientate which way your parabola opens. Okay? The line segment through the focus of a parabola and perpendicular to the axis of symmetry is called the lattice rectum. You don't need to know that. You don't need to know lattice rectum at all. Okay? So, most important, understand the relationship of where the focus is in relation to the parabola, as with the directrix. Okay? Any questions?
Is it always going to be like the same distance from the directrix to the bottom of the parabola?
Yep.
Is that like a defined
Yes,
number?
that's what's coming up next.
Oh.
Okay, and how you find that. Okay, everybody good? Alright, now, your equations. Now the form, if you look, we're going to look at the left column first. Okay, because this is the one we're most familiar with. This is the one that opens up if A is bigger than 0 and opens down if A is less than 0. This is the version that came when we did that little chapter of graphing. When we did 4.7 and we did completing the square and we did domain and range of it. Okay, that's that first columns part. Okay, that's where that came from. The form of equation was y equals a parentheses x minus h quantity squared plus k, vertex form, right? Okay, remember that? Opens up if a is bigger than 0, opens down if a is less than 0. Your vertex, hk, okay, right here comes from this h and this k. That's your vertex. The axis of symmetry is a vertical. Remember what the axis of symmetry is. It's that vertical line. That vertical line that goes through your vertex. So the vertex's coordinate is the same as the axis of symmetry's line. Okay, makes sense? Okay, so I'm going to draw a quick rough etch-a-sketch of a parabola. Thank you. Okay, not drawn to scale. I didn't want it exactly on the axis, so there's that. Okay, and the axis of symmetry is that y-axis. Okay. Now, the formulas for figuring out the focus and the directrix. So remember, the focus is the point in the middle. The focus and the vertex are going to have the same x-coordinate. Okay, see that? Because they line that same vertical line, right? This point is straight up from the vertex. So their x-coordinate is going to be the same. So h, defined in the vertex. Make sense? Everybody good? Okay. The y-coordinate on your focus comes from the formula, whatever k is. Okay, so the k of the vertex right there, how high up it is. And the distance between it and the focus is you add 1 over 4 times a. 1 over 4 times a. Where does a come from?
The vertex form.
The vertex form, good. Okay, the vertex form of the equation from right here. All right, see that? That's where this a comes from. Okay. So that's the way you figure out this. Everybody good so far? Okay. Now the directrix is going to be the line y equals. Okay, it's going to be y equals because it's a horizontal line. See that? So it'll be a y equals. And then this is the same setup of formula but from the focus's point, but instead of a plus, you move it down so it's a minus. Okay, see that? The only difference between the two is the focus you add it because it's above the vertex. The directrix you subtract it off because it's below the vertex. Okay.
Wait, where does the h go?
For the directrix,
Yeah.
there isn't one because it's the equation of a line.
Like K would be a Y.
Oh wait.
So like your Y or your dicentric should really be the
Focus
K.
is a point.
Right. Focus is a point, directrix is a line. Correct. Okay? Make sense? That's if they're opening up or down, right? Either way.
I thought these were opening sideways.
They are. That's where I'm getting to.
So that's just stuff we know.
That's most of, yeah, this is old stuff from here up. These two equations and how you find these 2 points are new. Okay? I'm not. We got a whole nother column to go through. Now, if you open left and or right, some things change. Okay? First thing that changes, your formula itself. You switch from being y equals to being x equals. Okay? X equals a, parentheses, y minus k quantity squared plus h. Okay? Your h and k still mean the same. Okay, because your vertex remains hk no matter what. See that? See how they're, come on, finger move. There we go. See how these are the same on your vertex? Yeah. Okay, for both of them. So h and k still mean the exact same thing. It's just in which one you're talking about it with, whether it's being with x equals a, y minus k, if it's on the inside, and h is on the outside, or if it's x minus h on the inside and k on the outside. Yep.
Did you just test?
No.
I'm pretty sure.
Well, maybe I did. I don't know.
What?
I meant to say
You're not
shift.
the only person.
Yeah, no, I definitely heard it. I mean, I heard it too, but like.
All right, now notice the differences though. Okay, from there the differences are vast. Your axis of symmetry through the vertex, remember, is now a horizontal line, so it's going to be a y equals line. All right, makes sense because the vertex is going through this way now. Your focuses, since your vertex, let me draw the vertex real quick on this parabola. There we go. Since your vertex and your focus lie on the same plane, same line rather, then now since that one's moving left and right and not up and down, your k coordinate stays the same. See that? See how it switches that? So hk, and instead now you still move up and down k. You change how far left or right you move. See the differences? Okay. You still move, it's still by h plus 1 over 4a or h minus 1 over 4a for both of them, though. See that? Okay, Mitchell?
I just have a- What's the point of the direction?
You'll see.
Because it just kind of seems like a little line hanging out
You'll see.
below it.
It is. There is a point. Okay?
It's like a weird horizontal
Right.
asymptote that's like not
Correct.
an asymptote.
O'Neill?
It just depends on this compound aspect.
Just finish. That's what she says. You will be given, this may be what you're getting at. You will be given the equations to these four.
On the test?
Yes.
Oh, that's so.
You'll be given these four.
Oh, you're amazing.
I know. Okay?
Like, they'll be written now.
Yes.
Oh, thank you.
You'll be given these four. Okay? You will have to know which one goes with which, though. Okay? I won't label this one goes orientated up and down and this one goes left and right. You got to know that. Okay? And the way you figure that out, here's where it's useful, your directrix line. Is your directrix a y equals? Yes. That means your directrix is horizontal, which means your parabola opens vertically. Is your directrix an x equals? Yes. That means your line is vertical and your parabola opens horizontally. Yes.
So your parabola should never touch your eccentric line.
Correct.
Like, how is this chapter gonna go?
Try to keep it simple. Starting off keeps it simple, okay? Write the parabola in vertex form. Identify the vertex, axis of symmetry, direction parabola opens. All right, just for a quick little review. We're going to complete the square on these guys and get it into vertex form. So we're going to factor out the 2. So y equals 2, parentheses, x squared minus 6x. You leave the plus 6 out. Remember, you complete the square on the middle part, so you divide negative 6 by 2, which gives you negative 3. You square it, which gives you plus 9. And then remember to balance, so you add in a plus 9 in here.
How'd you get the plus 9 again?
By
Divide
2 and then square.
divide negative 6 by 2, and then square it. Remember, since there's an a in front, you have a 2, you multiply it into 2 and 9 to get 18. That's what you really added in. Balance it off with a minus 18 on the outside. Okay, completing the square is very important in this chapter. Very important. Y equals 2. Factor that perfect square trinomial, x minus 3, y squared. Like terms gives you minus 12.
Yeah, how do you get 18? You said plus 9.
2 times
Oh,
Oh.
You're on the same side now. Remember?
The other side, so you have to multiply this side.
It's plus. It's because it's plus 18 here, so same side you balance minus 18.
Okay.
Okay.
I'm trying.
This isn't. Okay, so
How do you know if it's up and down or sideways?
that's what we're getting to.
Oh.
Okay. This one here, y equals vertex is what? HK and H would be 3 and negative 12. Good. All right, the axis of symmetry. Whoops. This is going to be the line through the vertex, x equals 3. You know it's up and down like normal because this is y equals. Okay, see that? That's normal. Y equals. Nothing weird.
Wait, why is it 3 and not negative 3?
Because it's
For the vertex.
that minus is x minus h. So h is just 3. Okay. And then this one opens which direction? Opens up.
How do the axis of symmetry?
Same as the x coordinate of the vertex. Okay. Alright, so the one we just did, okay, this is important. The one we just did will have, with the equations of parabolas with vertical axis of symmetry, have the parent function y equals x squared. Just like it's always been. Okay? Vertical axis of symmetry through your vertex. And they're usually written in the form y equals a parentheses x minus h quantity squared plus k. Just like it's always been. These are functions because they pass the vertical line test. Okay? Everybody good?
Wait, I'm confused about the y equals x squared thing.
What about it?
What is that? Like,
It's the parent function of a quadratic. All right. Now, once you get into parabolas with horizontal axis symmetries, that way you know what it is because it's going to either have one of two things. It'll either have x equals, like it does right here, or it will have y being squared, which as far as I'm aware is the first time you've ever seen that. That's how you know this one shifts and it's on the side. Okay, did everybody see how I did that? All right. These aren't functions because once you move a parabola to its side, think about a vertical line test. It's going to hit it twice, right? Okay, so these aren't functions. And the parent graph for these equations is x equals y squared. So it flip-flops everything. Okay? So that's where we're moving to. All right, everybody good? All right. Next one. Identify the vertex. Graphing parabolas. You don't actually have to graph it. Okay? Identify the vertex, axis of symmetry, focus, and directrix of the following parabola. Also state what direction the parabola opens. Okay. So the first thing you do, you notice whether you have a x by itself or a y and a y being squared, or you figure out what's squared. In this case, it is y squared. Okay, so if y is squared, that means you need to solve for x. Okay, so that's what we got to do with this one. We got to solve this guy for x. So that's what we're going to do now. So in order to do that, we're going to add y squared to both sides.
You do like 1/2 y.
Not yet. Because what do we want to end up doing on the right-hand side here?
Complete the square.
No. We want to complete the square.
So would you leave it complete
So
the
for
square?
now, there you go. Yeah. For now, leave this as 2x. Okay? Because we still have to get this into vertex form so we can figure out all this stuff. For whatever reason, my finger's very spotty today. Okay? So do the completing the square on this guy first, which will give you 2x equals. Nothing to factor out, which is nice. Y squared plus 4y.
How do you do that again?
Divide by 2 squared.
Divide y's by 2, which is 2, and then square it to give you 4. The plus 10 from the original, and then balance that 4 you added in with a minus 4. Do your like terms there and factor. So 2x equals 20y plus 2 squared plus 6. Now, you need to divide both sides by 2. Okay, how many terms are on the right-hand side? 2. Okay, so when you divide both sides by 2, make sure you divide both of them terms by the 2. Okay, and we want to make sure we write this in such a way when we divide it by 2 that it actually helps us with something. Okay, so how do we want to write this as? 1/2. Good. So x equals 1/2 y plus 2 quantity squared plus 3.
You see, you make it so much easier.
But why is it just 1/2 y?
Because
Oh, wait a
anything,
minute. So is your k?
Which means your vertex. And this, honestly, I think this is the hardest part. Okay? Remembering that your x and when your x is equals and that flips, so does your vertex parts. I think that's the hardest part. Everything else, if you think about it, all makes sense. Okay? If you draw out the parabola real quick, that all makes sense. The only real issue is your h and k flip-flop spots. So when you write out your vertex, and since it's x equals, you go to the back end for your h, which is 3. And then you go to your inside and do the opposite, which is negative 2 for your y. Okay? It's whatever's in here. See that? When y is in here, this goes in the y spot for your vertex. When x is in here, it goes with the x spot of your vertex. See that? Okay, so it does make sense, but it's hard. It's a little trick to remember. Okay? Since your vertex is 3, negative 2, and since we know, so here's what I do. Once I know that, I kind of draw me a little rink-a-dink kind of picture. So I go to 3, negative 2. I go out here. All right, cool. Okay, which means, and I know since it opens either left or right, I know the axis of symmetry goes this way. So the line is what? Y equals negative 2 for your AOS. Okay. We may not have talked about this since since A is positive on this one. Which way does that open? To the right. Okay, good. Which is helpful. Okay, since we know that, well, now we need to find the last two things. We need to find the focus. We need to find the directrix. Direct TV, but tricks. Okay? Directrix. It's kind of like DirecTV, how they play tricks on you, but directrix. Okay? Okay. Now, we know the focus is in here somewhere. And the focus is in line with your vertex. Okay, so from here to here, the focus has what point do we know? We know it has a y-coordinate of negative 2. Okay, we know that. Because it's in line with the vertex, which is right there at negative 2 also. Okay. In order to find the x-coordinate, you take the x-coordinate of your vertex, and you add 1 over 4a to it. A is what? 1/2. And you figure out what that is. So 4 times 1/2 gives you 2. So it becomes 3 plus 1/2, which gives you, O'Neill, 3.5. To be honest, you can put that as 3.5. I won't yell. I even have that in my notes as 3.5. All right. So that's your focus. Okay. Now and then to find your directrix, here's where knowing what kind of line it is comes into play. Since it's a left and right parabola, the directrix goes vertically, like that. Okay, which means that line is what? Starts with what? X. X equals. And you do the same thing you did with your focus, except this sign's what? Minus. So it's 3 minus 1/2, which gives you the line x equals 2.5, yeah. And it says also state what direction the parabola is open. Right on it real quick, opens right. Okay. Write that too. Don't just draw the little picture and expect me to see it. Okay. It's kind of like how those last questions went on the test with everybody just writing down numbers and not labeling their stuff for their zeros and asymptotes and whatnot. You sent me on a wild goose chase and I did not appreciate it. Okay. Okay. Now, they can also shift what they give you here. Okay, so now it's a little bit different. So now we're going to write an equation for a parabola with a vertex of negative 2, negative 4, and your directrix is y equals 1. Okay? So we're going to write an equation for a parabola with a vertex at negative 2, negative 4, and a directrix y equals 1. This is an example where at least, I'm not saying you have to, but I think just getting an idea of where you're at on the XY plane can help tremendously. So you know what you're looking at and you know what you're trying to find. Okay? So your vertex is -2, -4. So down here somewhere. Your directrix is the line y equals 1, which would be what?
Above it.
Horizontal and up here. Right?
So that means,
Yeah, it's stuck again.
that means your parabola opens down. Right?
Yep. Okay, since the directrix is there, you know the vertex is here, and we know the focus is where in relationship to the vertex.
Like,
Below it. Even more. See that? Okay, see how knowing the relationship between the three helps out? Okay? Helps a bunch. So we know it points down, which means A is going to be what? Negative. Good. All right. Now, to figure out what A is, you already have pretty much everything you need. Okay? -2, -4 is what? Label them. H and K. Your directrix is y equals 1. And since it's y equals, you know that the formula for that, since it's in the y equals part, is y equals K. Whoops, that was an ugly K. Try again. There we go. K minus 1 over 4a. Since it's y equals what I give you, you know that's the one you use. K is what? Nope. K is -4 minus 1 over. We don't know what A is. This Y is what? 1. Because this formula for the directrix, we are told, equals 1. And now you?
multiply by 4.
No. Add -4. So you get 5 equals -1 over 4a. Cross multiply, right? So 20a equals -1. Divide by 20. A equals -1/20th. Last thing you got to do is what? Yeah, actually go write the equation. Okay. Since your directrix is a y equals, right, y equals 1, so will your parabola. Okay, they always coincide. So y equals -1/20th x. H is -2, so this becomes what? +2 quantity squared minus 4.
So this isn't really that hard to see.
Yeah.
It's just flip.
All right, so write an equation for a parabola with a vertex at 1, 3 and a focus at 1, 5. You know your vertex is HK. All right, and when you go and plot those 2 points, let's see, H would be at 1, 3, which is about right there. That's the vertex. That's not a really good V. That's a little bit better. And your focus is 2 up from that. Right there. Okay? So, you know this parabola opens how? Up. Good. Okay? You know this parabola opens up, which means it's a y equals, which means when you write this out, the focus equation you want is k plus 1 over 4a, and it's going to equal what? 5. Okay, it's going to equal 5 because the x coordinates are the same thing. See that? The 1 and 1? I'm way too close on the other side. Okay. Since the relationship between a vertex and a focus is this line, the ones are going to be the same. But the 5 is what solves for this y coordinate. Okay? Now, if that was flipped, it'd be the same thing, it's just the variables would change. Make sense? You know k is 3? Cross multiply. 8a equals 1. A equals 1/8. Write the equation. Y equals 1/8 x minus 1. Quantity squared. Look. Write an equation for a parabola with focus at 5, 6 and a directrix at x equals -2. Oh, you're going to want to graph this one. That's the focus. The directrix is what?
The vertical.
A vertical line, x equals -2.
So it opens right.
So we know it opens right. Okay, see that? Because we know the vertex is somewhere in between these two. Okay? So, the parts you need to write the equation of a parabola are h, k, and a. That's what you need. You need your h, which is your x value of your vertex. You need your k, which is your y value of your vertex. And you need the a. So let's see. We need our vertex.
Wait, why would you have to graph this?
I'll show you don't have to, but I think it's helpful. Okay. What's the y coordinate of the vertex? Yes, you do know it. 6. Why? Because it lines up with your focus. Right? The vertex is literally somewhere in between these two. Between your focus and your directrix. And it has the same y coordinate then as your focus. So we know it's 6. Okay, see that? Okay, now we have two other pieces of information we can use then. We have the x coordinate from the focus, and we know the value of the directrix. Well, we're still missing how many parts? We're still missing 2 parts. All right, that's cool. Let's plug this stuff in and see what we figure out then. So we go h plus 1 over 4a equals 5 for your directrix, or for your focus rather. Okay, see that? And then from your directrix, you know it's h minus 1 over 4a equals -2 because of this part. All right. Makes sense on where those came from, yes?
Wait, where'd you get that? Where'd you get the second one?
From your directrix part.
You use them both equal to h. Just think.
The first one is
First one is the directrix, or the focus, I mean, sorry.
yeah.
Okay, since you know the directrix is 5, and it's with the horizontal parabola, so it's h plus 1 over 4a, because to get here, you add that 1/4 a part to the vertex. To get here, you subtract it off x, right? You're moving along this imaginary line between the directrix and the focus. Make sense?
Yeah.
Okay. Now what?
Then you put them equal to A.
You could set them both equal to h, but you also could what?
I was going to solve for H and then plug it in.
You could solve for h and plug it in. I have a better idea, and I knew I wouldn't get anybody since it's this way, because of the way it's written, which I did on purpose. So let me do it like this. Let's see if this triggers some brains. Make it a system. Because once you make it a system, what's h plus h? 2h. What's 1/4 a minus 1/4 a? 0. Hey, that's nice. What's 5 minus 2? 3. So h equals 3 halves. So you know your vertex is 3 halves, comma 6. Alrighty, makes sense? Take that 3 halves, plug, good?
Yeah.
Take that 3 halves, plug it back in, solve for a, doesn't matter which one. I chose the directrix one for whatever reason. Subtract 3 halves, so negative 1 4a equals negative 7 halves. Cross multiply, so negative 2 equals negative 28a. So a equals 1/14. You get that? Okay. Last step, write the equation. So you know your vertex is 3 halves and 6. Up here, wherever that would be, about right there. Since it opens to the right, it's going to be what equal? X equals 1/14, parentheses, y minus your vertical, so y minus 6, quantity squared, plus 3 halves. Homework for this set is page 603, 1 through 12. I don't recall this, so I'm going to say this anyway. If it says graph, you don't need to graph. Okay? There is no graphing through this chapter. Okay? We're going to focus on the writing the equations part, identifying which one's which.